Introduction Explanation Gasoline Natural Gas Engine Simulator CNG. And this over here looks like an air grid. An air compartment for an air inlet of an engine. Coolant water. Cooling water tank fan. Throttle position sensor. Then intake pressure sensor. Then the front oxygen sensor. After oxygen sensor. Exhaust pipe. This is a gas-controlled ECU. This is a water temperature sensor. The detection tank is used to control a water temperature sensor for the fan. This is a carbon solenoid valve. Then the gasoline compartment. Filter an impurity in gasoline. And then there's the gas tank. Filled with gasoline. This is the one for gas. Control valve controls gas entry. A trachea for combustion. A control using gas fuel. And then here is a switch that is manually switched. Can be switched. A toggle switch between gasoline and gas. This is a distributor. Ignition coil. This is a knock sensor on the inside. Mounted here on the bottom of the cylinder. And then here are the 4 fuel injectors. One and the other are the connecting cables for the high voltage package. The spark plug is in this one. There are 4 igniters in total. This is an igniter for the 4th cylinder. High voltage cable, this is a water temperature sensor. Water temperature has the sets of water temperature sensors. One group is for meters. One is for the computer ECU. And this is a control valve for gas. So this valve body to control it. There's the starter over here, the starter motor. And the gas pedal. And this one over here. A pressure gauge for gas. Then this is a filling port for gas. Then when we raise, connect with the outer tube first. Open this after connecting, you are loose. Then after the raise is done, let's turn this off first. Turn off the outside. Pull out the tube again. And here is an angry. This is the supply for this control valve. This control valve is divided among the 4 cylinders of the engine. Here. Turn it on when you give it gas. You can turn it off when not in use. Tighten and turn off. And the one above is one. A vacuum pressure gauge for an engine. Another one is a fuel pressure gauge. And here's the instrument cluster. Then the ECU of the engine. A relay module here. And the fuse. OBD diagnostic seed. And ignition switch. And here's a diagram of the system. And the signal voltmeter. And the voltmeter. An electrical signal meter for the throttle. And the water temperature. Then the battery voltage. And the signal voltage of the accelerator pedal. Let's start an operation. Before starting, let's tighten the battery head first. Power up the system. able to unlock the key. This is the oil pump relay. We can start the engine. Now it's gasoline. Reboot. My engine is now in normal operation. It's running on gasoline. Let's add the accelerator. This one here. So this is a toggle switch. I can switch to gas with a click. Engine operating normally. Perform a measurement test. We have a multimeter. We turn on the power inside. Do not start. Let's take a look at the corresponding fault no E. Fault no E. It's just an injector failure. It's the cylinder-by-cylinder injector fault here. Then let's measure it first. A voltage under normal conditions. There is no voltage now. Let's measure the positive and negative electrodes. It's a voltage-free process. Start with us and see if it has any signal change. Put us on that. Then found. Will this value change? Not as big as what just changed. Then it was also extinguished here. Normally about 12 volts. And now he only had one more than 4 volts left. We can test it on my side. On, off. Now is the time for failure. Its resistance is infinite. Then reset. It is a conducting. It means that there is a broken circuit in this one. Then fault R is the same. Fault no R is our no sun injector. We disconnect. It's also a short circuit. Let's test the voltage. Same as before. It's also over 4 o'clock. Let's try it in the car. We resume idling. After idling resumes, it is also close. One is 12 volts, one battery. And faulty. It is also a 4.0 volt. 4.2 volts or so. And the faulty light is. It doesn't light up. Fault no sun. Fault no sun is one of ours. Information pressure temperature sensor. It's installed here. Fault no sign. Okay, let's measure one of it. Signal voltage does not start when static voltage. It's a 5 volt. It should be a power supply. Not 5 volts. We disconnect the fault. After disconnecting this iron fault, we measure below. He is also close to a 5 volt, just like what we measured before. A normal voltage is consistent. Then to the sensor, there is no volts here. Then it means that there is an open circuit here. Let's measure that conduction again. Turns out he's also an electronic infinity, a process that belongs to the circuit breaker. Let's reset it and take a look. The battery is connected. There is also no failure, which is one of ours. A throttle position sensor. Put it here. Measure it. It's in. What is its voltage under normal circumstances? Also a volt. And then down there it's 5 volts. There's something wrong with it. It's a little over a volt. The throttle signal, it will and will change. Let's measure the conduction. It turns out it's a resistor infinity. Also a disconnected I reset. What about when it is reset? The voltage up here has also dropped. Let's press the gas pedal. There is also a failure to power off. After the power is cut off, he can turn off the power. Restart it. Normally, the values above also start to change. There's going to be a beep. It makes a noise when you step on the accelerator. It means that there is no problem with the throttle. It's a turbine head, a sensor. Let's check the voltage. There is no signal line in the middle. Now it's close to 8 volt. Let's measure the top. Here's 2. Let's turn the engine a little bit. No need to start. There will be a voltage change. It's 5 volts now. Let's break the fault. That fault on the measurement side. Here is a power supply of more than 0 volts. Recover. It's a 5 volt. Now he is just right. That tool just hit that sensor there. It has the highest voltage. Turn around again and he will. It slowly comes down. It's 0 volts. Let's test the connection again. Now test it for failure. And then here is in volts. This is normal. This sensor, in different positions on the engine camshaft. Its voltage. There will be changes. Just a change between 0.5 volts. Now it is 0. It's 40 now. Let's test the conduction. Its resistance infinity. It's a circuit breaker. Reset normal. The resistance is somewhere between 1 and 2 ohms. See the next glitch. The next one is fault no row for crankshaft failure. The crankshaft is the engine, ignition of the key to a converter. It's installed here. We measure a voltage within a normal. I found out it has a little over our clock volt. We measure above. It is also a our clock volt. Then we set the fault and try it. Here is also a our clock below. This sensor requires the help of an oscilloscope can accurately measure, but here we can also measure it. When AC voltage under normal circumstances. When we test the fault, let's cut off the power first. Then start. Take a look at it. That AC. See if there will be any changes. Then turn the engine, the faster it rotates. The value will be larger. Then it disconnects. If we measure it in open circuit, the engine won't start. Now it's ignition. We disconnect it. And now resistance infinity. Because there is also a camshaft signal. Damage a crankshaft signal. It will engage the engine computer. It will engage the camshaft signal. It can also complete an ignition start. Fault no key. Fault no key is one of our oil pumps. The oil pump should be given a negative value. Because this is the time for these two. We are turning off the key. When opening the key, it will work for a while. Because of this relay, it will light up. Take another look. It also has a voltage. I have sharp volts on this light and it goes out. We broke down. Let's turn off the key again. Open the key. I found this relay is not on. Below is the voltage change. Let's look at the top. Close it again and try again. Still no voltage. Let's measure the conduction again. It's also an open circuit failure. We reset. Then open the door. Then we turn off the key again. Open again. This relay is on. It also has voltage. A sharp volt power supply. This is the negative electrode controlled by the oil pump relay. And then an ignition coil here. Let's try a voltage at which it works normally. The one given here should also be 1. The signal on the negative electrode. Also a sharp volt. Let's disconnect and try it. Found that he did not. What changes? See below. This sensor. Let's put it back together. Same here. What about this sensor? It can only be detected by using a wave tester. It's installed here, so we have no way to detect it with a multimeter. There is also fault number 10. So we can try this failure phenomenon. 8 and 10. Start again and try fault no 8 and no 9. A fault phenomenon of a fault. Try number 8 first. This engine is shaking a lot. Only 2 cylinders work. Now it's fault number 9. Same thing. The engine is directly turned off, because a signal controls the ignition of the 2 cylinders. Setup fault. That is, the engine has the cylinders left to work. It turns off very easily. Take a look at fault number 10. It's a water temperature sensor. Right here. It's a water temperature sensor. Measure one of its signal voltages. It should also be an electrical value measurement. A sharp volt. Sharp volts above. Disconnect and try it. Disconnected and found it was only 7.8 volts. After recovery it is sharp volts. Further up, it has a certain pressure difference. Above is 12.7. Here's 7.8 volts. I'll measure that on and off again. This is the main axis and infinity. Reset. After reset it is a conduction. Then 1112. It's the gas pedal failure. Just the gas pedal here. We can measure fault number 11. Fault 11 it is. 15 volt, 1 voltage signal. Me too. It's 5 volts until it fails. Then we now break the number 11 fault. It's still 5 volts. The computer is given. It has electricity, just 5 volts. 5 volts given out. He didn't hit the gas pedal. He may exist in the middle. A phenomenon of a broken circuit. Measure the conduction. It's also an open circuit. Then reset. Reset it and it turns on. And the same is true for 12. Let me check the static voltage. This is the signal. That one just now is 5 volts, which is the power supply. I press the pedal. It will change. Before the above fails, it's all the same. So now we're going to malfunction. Fault no 12. After getting on it, I found this computer. The above one has no voltage. Look below. There is still voltage down here. Let's press the pedal. This shows our. The pedal is no problem. If there is no voltage to the engine computer, it means that there is a disconnection between this. Let's measure it again with the on gear. It's also broken. We reset. Then you can. Fault detection is completed. Installation precautions during training. Just this battery. We're going to disconnect it after the training is done. To unscrew it. Otherwise, it will cause this battery to lose power and it's this water tank. After the water temperature of the water tank engine is hot, then it will turn. Just let's not go near here. Don't use it either. Put your hand in. And the belt is the same here. Pay attention to safety. There is also a gas refill here. That's when we're filling up the gas. Be sure to close this place first. Then take over. Open here after taking the tube. Then close it again and open the air port on the outside. Then add it to this air pressure after it is normal. Let's shut this down. Turn it off and then turn off the outside. Only then can this connection port be opened for it. And this left. In the heat of an exhaust pipe. Let's not touch it. To avoid burns. Panel these terminals. We don't need wires to disconnect it, so as not to cause a system to burn down. Don't disconnect the positive electrode for these ground wires.